Hey everybody, it's Miss C, fourth grade teacher at Syracuse Academy of Science and Citizenship Charter School. So we're moving on from weather. I think you all did a fantastic job and you learned about a lot of different ways that weather are formed in our atmosphere. And now we're going to be talking about waves. So waves are important because a lot of our information we get through waves. We get our TV through certain types of waves. We listen to music and that travels through waves. We go to the beach and we see waves. So we are going to be learning exactly what types of waves there are today. So here we are starting on a new format or a new site called TCI, and this is something that we might be using next year. So it'll be good for you all to see exactly how it looks, and I really like it so far. It has a lot of awesome things. So our first question is about waves. So if you think about different types of waves, maybe you all have seen a crowd do the wave, or maybe you've been a part of it. So we're gonna look at this here. We see a big crowd. I'll even expand it. All right, we see all these people. We see a huge crowd of people. Now we get to see them do the wave. Now pay attention to how it happens. It started over here in the left-hand corner. Let's watch it one more time. It's starting over here in the left-hand corner and up, and now their hands are down and now their hands are up. So we see that it goes up and then comes down and goes up and goes down. If we were in class, we would all be doing the wave right now. I really wish we were, but we will be in class again sometime and we will definitely do the wave. So here is an interactive part of this site that I really like. So it says, think of what you already know about the different types of waves and their similarities. Write questions you have. One of my questions would be, do all waves travel at the same speed? Maybe you have a different question. If you do have questions, make sure you put those in your exit ticket at the end because I would love to answer them, or if I don't know the answer, I will definitely find it out. All right, it says, by the end of this lesson, you will be able to explain the phenomenon at sporting events the crowd doesn't move called the wave. So we are going to be using models, and if you know what model means, you know that it is just a smaller replica of something to show a much bigger thing in life, or maybe not much bigger, but maybe something that we don't usually see. So right now, if you were sitting in the room with me and I was talking to you, you wouldn't see the sound waves traveling out of my mouth as I talk, but we can make a model of it so that we can see, because we know that sound does travel in waves. So for each model of a wave we are shown, we're going to follow these steps. We're going to carefully examine the model. We're going to read the text on the slide, pay special attention to the words in blue, and then we're going to annotate the image by copying down each blue sentence and drawing an arrow to the place in the image it best connects. So we know that waves travel in water. So water waves, we see a picture right here, and we see that when waves make this arc at the top, this is called the crest. And then they travel down at the very bottom. This is the trough. So up is the crest, down is the trough. And when we see this line that just goes through the center of each one of these crests and troughs, it's kind of the halfway point between these 2 points, right? And this is called the rest position. So if there were no waves, the water would just be resting at this position. And we know that the waves are traveling in this direction. So they're traveling from left to right. So a wave is a repeating pattern of moving matter. A water wave is a wave that moves along the surface of water. Like all waves, water waves move in repeating patterns of crest and troughs. A crest is the highest point of a wave, you see here. A trough is the lowest point. Crests and troughs form around a rest position, or the position that matter is in before a wave travels through it. So like I said, if there was no wave traveling through the water, then this is where the water would be resting. And this is a very important point, that water is a repeating pattern. So we learned about patterns in math. Patterns exist all around us, and we know that they are ways that we can send and receive information as well. And this is, I think, is the most important point, is that a wave is a repeating pattern moving through matter. So this wave has to move through matter, and the matter it's moving through is water in this case. So let's watch this video. When you throw a pebble into a pond, a wave spreads out and forms a pattern. So here we drop the pebble and now the waves, and you see it is a pattern going around symmetrically in a circle, traveling out at all points. Let's watch it one more time because it's really cool. And you could even try this at home. Throw a rock or a pebble in. Maybe if you have your phone, take a video of it in slow motion and you'll see that pattern. Now, waves on a string. We can also move waves through different types of matter. So string, for example, again, we have our crest, the highest point, our troughs, the lowest point, and then our rest position if we weren't having a wave travel through this string. So another example is traveling through a string. A wave on a string also has a repeating pattern of crests and troughs. To make a wave on a string, lay a rope or string on the ground. The rest position is where your hand starts. As you shake one end of the string, the wave travels along the string away from you. So this is another thing that you could try. Maybe you have a shoelace, maybe you have a string, maybe you have a rubber band that you cut, and now you have just one long piece of rubber band, and you can test out how waves move through those different types of matter. And just like water and just like string, waves can travel through a flag. So maybe you've been outside and you've seen the wind blowing and you see that the flag is moving. So where do you think the crests and the troughs would be on this flag? Well, where you get to show it. So here is a crest, here is a trough, the rest position. So this is how water moves in, or waves move in water. So what I am going to do is I'm going to label mine. Now I see these darker parts right here. See how it's more shaded right here? That is going to be, I'm going to put a T for trough because that's the lowest part, the lowest point. The highest point is where the water is closest to the sky. So here is the crest. This is a little bit trickier to do, but we know that the trough is going to be the lowest point and the crest is going to be the highest point. So where that water starts to form that top wave, that's going to be the crest. Now I get to show that on the flag. So where do you think I should put the crest? Take a second to think about it. The crest is the highest point. So it's kind of like an arc. So the crest would be the top of this dark band, this dark stripe. The crest is going to be here. The trough is going to be right here. This is the lowest point. So the crest and the trough, and we see that repeat throughout all of these. And we have one last one to do. This is a sound wave. Now sound moves left to right. So we see that it moves from here all the way over here to your ear. And the crest is going to be the top and the trough is the bottom. It doesn't necessarily have that arc in it. So here we have a person talking and we see those lines, they're kind of light, but I know that the crest is going to be up here. Oops. The crest is up here and the trough is down here. So the biggest thing to understand is that the crest, we say a wave is cresting when it has that big arc at the top and maybe has a little bit of foam at the top. That's just the highest point of a wave. A wave of water, I mean, when we say it's cresting, but any type of wave has a crest and it has a trough. And it will, any type of matter would have a rest position that a wave would travel through. And the last bit I want to do with you is a little bit of vocabulary. So let's try to figure this out together. It says, A, blank is a repeating blank of moving matter. A wave has crests and troughs. The blank is the highest point of a wave. The blank is the lowest point of a wave. Water waves, waves on a string, and sound waves all move through blank. The crest and trough form around a blank, or the position that matter is in before a wave travels through it. But matter moves differently in various types of waves. Scientists blank waves by how their matter moves. Now let's look at the words that we have in our key bank. Trough, classify, matter, pattern, wave, rest position, and crest. A blank is a repeating blank of moving matter. I'm going to say a wave, because we've been learning about waves. A wave is a repeating what of moving matter? We learned that a wave is a repeating pattern of moving matter. A wave has crests and troughs. The blank is the highest point of a wave. We learned that the crest is the highest point of a wave, and the trough is the lowest point. Water waves, waves on a string, and sound waves all move through blank. Well, if you're not totally sure what the answer to this one is, I can go back all the way to this first sentence. It says a wave is a repeating pattern of moving matter. So I know that sound waves, water waves, and waves on a string all move through matter. The crest and trough form around a blank, or the position that matter is in before a wave travels through it. If you remember, all of those models showed the crest, the trough, and in the center, or they were around the rest position. And another clue that I know is the rest position is that it says matter or the position that matter is in before a wave travels through it. Well, before it's at its rest position. Water is flat before it has a wave move through it. But matter moves differently in various types of waves. Scientists, our last one, what do scientists do with many things? They classify. Scientists classify waves by how their matter moves. Now, let's check and see how I did. Check my answers. We got them all right. We did a great job. All right, stay tuned for your social studies lesson on Wednesday and then our fun experiment Friday where we're going to test out waves and we're going to be able to feel some sound waves. All right, I can't wait to see you all then, and I hope that you have an awesome day.